Hello and welcome. In this video, I'm going to continue my video series on embedded C programming by exploring the selection construct. Embedded C support the following selection constructs: if else, else if, and case. Let's explore these constructs further. Let's start with the if construct. Here is the flow chart showing the if construct. So the program flow enters into this condition. It tests for the condition. If it's true, then these statements will be executed. If it's false, then nothing is done. The format for the C code would be an if followed by the condition in brackets. And if the condition is true, the statement or statements within these curly brackets will be executed. If the condition is false, then it will come out of this and nothing else will be done. Now let's take a look at the demonstration code. Here I start off with the include directive instructing the compiler to include this particular header file during compilation. And the program or source code starts off with main. Just a quick reminder, all C program must contain a main function. Now within this curly brackets, we have the if construct. So here's an if, and in brackets is the condition. Before I describe the condition, I just like to talk about this equal sign. Basically, that is equal to and is a relational operator and is used for making decision. So let's come back to the condition. So if the condition is P1 equal to 01 hexa, the 0x here denotes that 01 is a hex number, a hexadecimal number. So the condition is if P1 or port 1 equals 01 hexa, if it's true, then you execute this statement. And basically this statement here says assign 55 hexa to P0 or port 0. If this condition is false, it will come out and does nothing else. Okay, before we go any further, let's take a look at the relational and logical operators. So this is the greater than, and this is the greater than or equal. This is less than, this is less than or equal, and this is equal, with which you encountered earlier. And this is not equal. This is a logical and this is a logical or, and this one here, a logical not. Okay, so we are in the Kyle Microvision. Before I start the code demonstration, I assume that you know how to create a Kyle Microvision project and that you know how to include the source code or the C file into that project. Okay, so let's get started with the demonstration. So we go to debug. This tab here, the debug, start stop debug session, select that, and evaluation copy, click OK. Right, now since we are dealing with port 1 and port 0, so we'll go to peripherals. There's several options here. Go to I/O ports. As I mentioned, we need port 1 because the code requires port 1. So we have port 1 here, parallel port 1 here, and we need port 0, P0. So port 0, yeah. So we have these 2 ports that we need for this code demonstration. Notice there are 2 arrows here, one in blue, one in yellow, and it's pointing to this line, line 5. And in line 5 is the if, and the condition here is if this condition is true, then it will execute this statement. Now, to make sure that, so we set up port 1 first, P1. So 0, 1 hexa, so in binary that would be, this is port 1, so we click, uncheck all this, except for the least significant bit, because in binary, this one would be 0, 0, 0, 0, 0, 0, 0, 1. This is in binary, in hexa is 0, 1. So we set it up. We set the condition. Now put the cursor back at line 5. Now let me just show you, go to debug. I'm going to use the step function, which is F11 key on the keyboard. So I'm going to use F11 on my keyboard. I will single step. That means I will execute the instruction one at a time. So F11, so go back, make sure the cursor is at line 5. That's the first instruction we want to execute. So now we have already set up the condition, so this should be true, and this statement here that will put 5, 5 onto P0. So let's step it through and watch P0. Right, so now we execute, so because the condition P equals 0, means 0, 1 hexa, if that's true, so now we execute this, and we have 5, 5, that's in binary is 0, 1, 0, 1, 0, 1, 0, 1. So that, and since that is done, nothing else to be done, so it ends. Now, let's restart this debug session. Go to debug, stop it, now start again. Now this time, I'm going to single step again, but I'm not going to set up this condition here. So this time the condition here would be false. And now it shouldn't execute this statement. It will come out and will stop. So let's see if that is true. So I'm going to use F11 again to single step. So P1 is now all ones, FF hexa. So if I press F11 single step, it should bypass this one and end the program. Yes, it does. It does. Okay, so let's take a look at the if-else construct. And here we have the flowchart for the if-else construct. So the program flow enter into the condition portion, and if the condition is true, then the path will take us to this statement or statements. This will be executed. If the condition is false, then the program flow will go down this way and will execute the statement or statements here. Now let's move over to this side. Here is how the C code will look like. So we have the if here, followed by the condition. And if the condition is true, then this group of statement or statements will be executed. Else, that means if condition is false, then this statement or statements will be executed. So let's take a look at the demonstration program. As usual, I will start off with the include directive to tell the compiler to include this header file. And then you start off with void main. Remember, all C program must have a main. Then you arrive at the if, and here in brackets is the condition. So if port 1, P1, is equal to 0, 1 hexa, remember 0x here is showing that this is a hex value. Then if this condition is true, then this statement here in green, that will assign 55 hexa to port 2, P2. Now it doesn't have to be color coded. I put it in color for explanation purposes. So if the condition is false, else, then this statement here will be executed. That would assign this value AA hexa to port 0. Okay, so let's look at the if-else construct demonstration. So I've uploaded my project here. I've got my source code here. So I'm going to, okay, let's clean the targets, rebuild the targets. So we got 0 error, 0 warning. So we go to debug session, start, stop, click OK on that one. And okay, so we have got the peripherals, P1 here, P2, port 2, and port 0, which is this one here. Now, if you have forgotten where I've got this from, you just go to peripheral, I/O ports, and you can see port 0, port 1, port 2 been checked, and that's because it's been displayed here. Port 3 is not used, so it's not checked, and it's not appearing here. So that's where I got it from peripherals, I/O ports. All right. So now let's start the debug session. So I'm going to set up for this condition so that it's true. So which is port 1, so it's 0, 0, 0, 0, 0, 0, 0, 1. So that is binary. And in hexa, that is 0, 1. So the condition is true. So this statement here will be executed. So that is displaying 55 hexa on P2, which is this one here. All right, so I'm going to use F11 to single step. So, okay, so it's true. So we're now here. Now watch P2 or parallel port 2. It does. So it's 55 in binary is 0, 1, 0, 1, 0, 1, 0, 1. That's binary, but in hexa is 55. And now let's see what it does. Single step again. It should exit the if-else construct. Okay, it's done. All right, it's stopped. It has stopped. Right. Let's stop the debug session. Reset it. Start the debug session again. Okay, so this time I set for a condition where this condition is false. So I'm going to leave P1 as it is with 8 ones, that is FF in hexa. So this condition is no more true, it's false, and then it should execute this. Alright, so let's see, step it. Yeah, it does because it's false. So now watch P0, we should see AA display. Well, it would be in binary here. So, yep. So AA in binary would be 1, 0, 1, 0, 1, 0, 1, 0, which is the opposite of 55. And the program has ended, basically. That's it. Okay, just allow me to just summarize the if and the if-else construct. Now for the if construct, if the condition within this bracket is true, then this statement will be executed. However, if it's false, nothing will be executed. It will exit. Now, for the if-else, if the condition within the bracket is true, then this statement here will be executed. However, if it's false, or if you have an else, then this will be executed and it will exit. So let's take a look at the if-else construct. So here I've put in 3 conditions. So in theory, you can have many conditions, but we'll stick to 3. So for the first condition, if it's true, it will come down this way and then execute the statement or statements. And then after that, it will exit. Now, however, if it's false, it will then check for the second condition. If it's true, it will execute the statement or statements and then exit. However, if it's false, it would check for the third condition. And if it's true, it will execute the statements or statements and then it will exit. However, if the third condition is false, it will come down this path, execute this statement or statements, and then it will finish and exit. Let's take a look at the sample code, or the code I'm going to use for the demonstration. So we start off with include the header file. Then we have the main. Now for the first, here is the first condition. If it's true, it will execute this and then exit. Else, it will check for this one. If it's true, it will execute and then exit. Else, if it's false, then it will check for the third condition, execute it, and exit once it's done. So let's take a look at the demonstration. Okay, so let's take a look at the else if construct demonstration. I've uploaded my project here and the source code is here. So I'm ready to build the targets. So it's 0 error, 0 warning. So let's go to the debug session, start the debug session, evaluation mode, okay. So now I have, I'm only using P1 for the input to test the condition and P0 for the display. So let me just set up the first condition. So it's 0, 1 hexa. So in binary that would be 0, 0, 0, 0, 0, 0, 0, 1. So this condition now is set up. So it should be true. Again, I will use the F11 single step function to execute this. So since this condition is true, then it should execute this statement that will display 55 hexa onto P0. All right, so let's step through. Yep, now it will display 55 on P0. It does 55 in binary would be 0, 1, 0, 1, 0, 1, 0, 1. So that is in binary for 55. And now that the condition is met, it should exit. Yes, it does. The program has ended. So let's reset the debug session. So stop the debug session. Now let's get back into it again. Let's start the debug session afresh. Now let's test the condition for this. P equals to 1, 0. So P1, 1, 0, so 0, 0, 0, 1, 0, 0, 0, 0. So now it's 0, 0, 0, 1, 0, 0, 0. So that is 1, 0 in hexa. Now it should bypass this one and get down to this one. because this condition is no more true. So let's see. Yes, so it's gone down to check for the second condition. Now that I set it up for the second condition, it should now execute this assign AA to P0, which is the inverse of 5, We should see this here. So let's step it through. Yes, now watch P0 or port 0. Yes, so it now is 1 0 1 0 1 0 1 0, which is AA. And this should now end because the condition is valid, it's true. So, yep, and it stopped. Right. Now, let's test for this condition. So let's reset this thing. Stop, start, stop. Start again, start the debug session again, afresh. And so now we set up for this condition 1 1 for P1, so 0 0 0 1 0 0 0 1, so it's 1 1, and we should execute this statement here, which is F0. Let's see. So it doesn't detect. So now let's see what happens. It should meet the condition. It does. It's true. So now it should output F0 onto P0. Okay, and it does. So it's 1 1 1 1, which is F. 0 0 0 0, so it's 0. So it's F0, and it should end. And it does. Okay, so we see how the else if construct operate. So let's move on to the next one. Okay, now let's take a look at the case construct. The case construct compares the condition with the case constant. Now, if the condition matches the case constant in this case is the one in red, and if this condition matches the constant, then the statement or statements here will be executed, and when it encounter the break statement, it will then exit. Now, if this first case constant does not match the condition, it will then compare it with this one, with the next one, with the next case constant, and if that matches, then the statements will be executed, and when the break is an encounter, it will exit. Now, if none of the constants matches with the condition, then the default case would be the statements attached to the default case would be executed. So, and then when that is done, it will just exit. Now the format, the C code rather, is shown here, and here's the switch with the condition, and within the curly brackets we have all the case including the default. So there is the constant, and if the condition here matches this constant, the statements will be executed and they break, and that will be the end of that. But if that doesn't match, then it will move on to compare with the next one, and if this matches, then the statements will be executed, and the break will then stop it and exit. If none of this constant matches with the condition, then the default case will statements would be executed, and the code and the program will finish. So let's take a look at the demonstration code. So I have the include directive to include this header file, and then here is the void main, and I declare the input as the integer type, and then assign P1 to input, and then the switch will use the input as the condition. Then it will then compare this condition with the first case constant here. If it matches, then this will be executed, which is 0, 1 assigned to P0 or port 0, and once that is done, it breaks and that ends. Now, if that didn't match, then it will then compare it with this constant here. If it matches, then this would be executed. That is assigning 02 hexa to P0. Once that is done, when the break is encountered, it will break off and end. Now, if none of these constant matches with the condition input here, then the default case would be executed. In this instant, that will be AA hexa assigned to P0. Once this is completed, it will then exit. Let's take a look at the demonstration. Okay, so now let's take a look at the case construct code demonstration. So again, we start off with the include reg52.h header file, and we gotta have the main. And for this demonstration, I'm going to declare a variable called input as an integer int, and I then read P1 port 1 and assign it to input, and then here we do a switch which would then compare this condition input, the variable input, with the case constant here. Alright, so let's do the project, rebuild all target files, 0 error, 0 warning. So let's go to start stop debug session, click OK for evaluation mode. I need P1, which is here, port 1, and port 0, P0 for the output. So now I'm going to test the case for 1. This case constant here is in decimal. So translate to 8-bit binary, that would be 0, 0, 0, 0, 0, 0, 0, 1. So, and I'm watching it here. No, let me bring up the view, watch window, watch 1, enter the expression, double click, type in, input, enter. Alright, so I'll step through it using F11. So input, now I'll read the contents of port 1 and assign it to input. Yep, so the input variable here is now 0001, and that is the condition here. Now the switch input will compare it with the case constant 1, which will be equal. It will match. So yep, it matches. So now we output 0, 1 to P0, and it'll break and end. That's it. Right, let's reset the conditions. Stop the debug session. Start it again. This time I'll make the condition to match this one. So this is decimal 2. So here I would do 0, 0, 0, 0, 0, 0, 1, 0. That would be 2 in binary. So that should matches. So read that into input. Yeah, got 0, 2. Now do the switch. Compare the input with the constant, case constant, and it bypass this straight away. Go here because it matches the 2. So output 02 hexa to port 0. Yes. Break. That should stop it. And that's it. Right. Let's reset the conditions. And now go to debug again. Start it. Click OK for this. Now, I'm going to leave the P1 as it is with all 8 ones. So it's FF in hexa. So now it would not match any of the case constant. It should go for default. So F11. Yes, it's FF, just as the port 1 indicates. So it'll bypass case 1, case 2, and go to default. Yes. And it will output AA hexa to port 0. So the alternate bits will be switched on. Yes, it is. And it breaks and it finishes. And that's it. Okay, before we conclude this video, let me just do a quick review of the demonstration code that we have just seen. Now, and compare it with the program of code on this site. Now, this is almost identical to this, except if you notice the break statement is missing from here. Now let's go back to this code here. So if the condition here is compared with the constant, if the condition and the constant matches, then this statement will be executed, and after that, when it encounters the break statement, it will come out. It will not move on to the next one. It will break, come out, and that's it. Now, if this doesn't match, then the condition here or input will be compared with the next one. If it matches, it execute this, and then break and come off. Now, if none of the case constant match the condition, then the default statement will be executed, and this statement here will be executed. Now, compared to this, without the break, the condition here, the input will be compared with each of the constant without any break until it finishes with the default. So it goes right through comparing. And that's the difference between the two if you ignore the break. Okay, so that's it for this particular video. I strongly encourage you who's watching this video to try out the code that I have used in this video. I would include the code that I've used in the link given in the description, but I strongly recommend that you type the code in yourself and compile the code and then step it through, and I think that you will learn a lot more that way rather than just use my code, input it into the IDE. I think by typing the code and trying things out, you will learn a lot more. Okay, so that's it for this video. Thank you for watching, and I'll see you in the next video. Bye.